Okay, now I'm going to show you question number 36, how to solve it. Okay, the function given is this one, ln something, and then you are asked to show this first. And then you are used to show the Maclaurin series for fx, we are going to do until x3. So we are going to differentiate until the third derivative. Okay, so after only we come to the last part. Okay, so now see how are we going to differentiate to get this. This one we have to differentiate twice. Okay, d2y dx squared of the second derivative. Okay, now look at this. This is the one given. Okay, we are going to differentiate. Okay, first of course we are going to differentiate the first one. Okay, f prime x, differentiate the ln, you will get -1. Okay, sine all this, and then ln become -1. Then after that you have to differentiate the bracket here. When you differentiate sine, you will get cos. And then you differentiate this one, you will get 1 over square root 2. That's why we have 1 over square root 2 here. Same thing here, when you differentiate the cos, you will get negative sine, then x over square root 2, and then after that you differentiate this one, x over square root 2, you get 1 over square root 2. So I straight away write it here. Okay, so you will get this. Okay, this is what you get. And then of course -1, that is the denominator, so we bring it down, that's why we get this. Okay, so now we get this. Okay, so because we are going to find, okay, and then the square root 2, I will just bring it over. Actually the square root 2 is here, I factorize. Okay, I put it here. Okay, now you want to differentiate. Now we are going to second derivative. That means we are going to differentiate again. So if I want to differentiate here, you see this is a quotient rules. That means we have to use the quotient formula where this is square and something else, isn't it? Okay, or we can write it like this as well. You can bring all this over and put it over here. That's why I get square root 2, this one, and then f prime x, and then you get this. Okay, so now you compare these two. Which one is easier to factorize? Of course, for me, I feel that this is easier rather than this. Actually, they are the same. You will get the same result. But of course, we look for the easier one. So this will be easier. Okay, so you want to differentiate this. Now I am going to differentiate this. You see? Okay, when I want to differentiate this, here. This one, I just keep it. Okay, I differentiate this. This one I differentiate. Just as I said, 2 person using the toilet, this one use first, and then this one waiting outside. Okay, I differentiate this like just now. Sine, I get cos. Differentiate the 1 over square root 2, I get 1 over square root 2. Cos, I get negative sine. Differentiate this, I get 1 over square root 2. Okay, then plus. After that, this one have to wait outside. Wait outside the toilet. And then the f prime x differentiate, you get f double prime x. Okay, so this is what we get from differentiate the left hand side. Okay, now we differentiate the right hand side, you will get this. Differentiate cos, you will get what? You will get negative sine. And then differentiate this one, you get 1 over square root 2. Same thing here, sine minus sine. You differentiate, you still get negative cos. And then differentiate this, you get 1 over square root. So this is what you get. Okay? Okay, now you see. Then I simplify. The square root 2, I cancel it off. I cancel off all the square root 2 here. I multiply inside. Then I get this. And then this is square root 2. This one. And then equal to, okay, the square root 2, I just bring it out. Okay, I factorize. I just take it out like this. So this is what I get. Okay, now you see. You look at this one and this one. Actually, this one I can change into this type. I can change into this form. So easier. If not, now if you see, this is f, this is the second derivative. If you want to go to third derivative, then this will be very, very complicated. Okay? It will be very, very complicated when you want to differentiate this. It's not easy. So what we do, I try to change it like this. I can divide, you see. I divide every term. I divide every term by this. Why I divide? Because I want to get like this, something like this. So once I divide, I will get this. You see? When I divide, here I divide. This one is cos negative sine, and then divide by this. Okay? So actually this one just now, afterward will be this. And then here when I divide with this is 1. This will be 1. Same thing here, I divide, this will be 1. Okay, so you see, after you divide like that, you will see that this will be much easier. Rather than you look back at this one, you want to differentiate this. I also cannot do, okay, because so complicated. That's why every time when you do this type of question, you have to see before that what you have got here, what you have got here, and we try to substitute and see. So it will make the problem easier. There you see, what is this? This is actually from here. Okay, is it exactly the same? So you just substitute this one, square root 2, f prime fx, and then f prime x, then this one. Okay, so f prime a and prime a x square. So this is what you are going to show. Okay, or you will get this. So this is what we are going to show in the question. So you see the question just guide us to use the easier method. Then you see we are asked to show this. Okay, here. Okay, so we have got this. So actually the question just guide us how to get the easy way. Okay, of course you don't go and differentiate this one. So we try to simplify until you get this. So you see, if you get like this, then it's easier. Now you can differentiate many times. Okay, of course we are going to third derivative only. So you differentiate this, you get f triple prime x. Then this one, when you differentiate, you bring down the 2, then here you get 1. Then after that, you differentiate the bracket, f prime, you get f double prime. Then you differentiate the constant, you get 0. So this is what you will get. Okay, so this is what you will get. Okay, so because we are going to use the Maclaurin, okay, now as you see from the question, what are we going to do? We are going to use Maclaurin series to show that fx can be written like this. Okay, so what we are going to do now, we just substitute x equal to 0 and so on. So here I substitute x equal to 0, I will get, okay, so I just substitute. Okay, so you just from 2, you can just refer back. Okay, what is 2? What is number 2? What is number 3? What is number 4? So this is all what I will get. Then I just substitute inside to our, okay, the Maclaurin theorem. So that finally I get this. Okay, so after that you want to find the limits. Okay, so you want to find the limits and then you want to integrate. Okay, so I will show you how I get this. Okay, you want to find the limits, you just substitute whatever fx we get, so we can factorize, and then after that you substitute, then you get the answer is this. Okay, then when you come to integrate, you just substitute our fx, like this, you just substitute, and then you integrate. Okay, then you just put in the value here, then you get the answer. Okay, so here you just substitute the fx, you just substitute the fx inside, and then you see that the x can cancel. Then this is what you get. Then you just integrate term by terms. Then after that you just put in all the limits. Then you use calculator, then you can get the answer. Okay, so this one, I think this one no problem once you get the series. Okay, actually this question I want to show you how to get the series. Okay.